Welcome. Today we'll learn how to find the inverse of a function. Let's find the inverse of the function f of x equals 3x minus 2. Let's first understand what an inverse function does. If we plot our original function, it looks like this. The inverse function essentially undoes what the original function does. If f of x takes an input and multiplies it by 3, then subtracts 2, the inverse function will add 2 first, then divide by 3. To find the inverse function, we follow these steps. Step 1, replace f of x with y. Step 2, swap x and y. Step 3, solve for y. Step 4, replace y with f inverse of x. Let's apply these steps to our function. First, we replace f of x with y. Y equals 3x minus 2. Next, we swap x, and yx equals 3, y minus 2. Now we solve for y. First, add 2 to both sides. X plus 2 equals 3y. Then divide both sides by 3. Y equals x plus 2 divided by 3. Finally, we replace y with f inverse of x to get our inverse function. F inverse of x equals x plus 2 divided by 3. Let's verify this is correct by plotting the inverse function. Here's our inverse function in red. Notice that the inverse function is a reflection of the original function across the line y equals x. This is always true for inverse functions. Let's verify our inverse function works by testing some values. If we input x equals 1 into our original function, we get f of 1 equals 1. If we then input this result 1 into our inverse function, we should get back our original input of 1. Let's check. F inverse of 1 equals 1 plus 2 divided by 3, which equals 1. It works. To summarize, to find the inverse of a function, we 1. Replace f of x with y, 2. Swap x and y, 3. Solve for y, and 4. Replace y with f inverse of x. The inverse function undoes what the original function does, and when graphed, it's a reflection of the original function across the line, y equals x.